Hey everybody, it's Mr. Kessler. Yes, it's me down here in the little box in the corner. This is our first flipped classroom video. I hope it works well for you. Today we're talking about solving systems of linear equations. That's this whole chapter. Today the first one we're going to work on is graphing. So, solving a system of equations consists of two or more equations. The solution to a system is a value for x and y that satisfies both equations. So what we're suggesting is that 2, 3, x equals 2, y equals 3 has to fit in both of those equations in order to be a solution to that system of equations. So let's substitute 2 in for x and 3 in for y. Does it equal 14? Yes. So the first one, it works. How about the second one? 2 times the x value is 2 minus 3 is the y value. 4 minus 3 does equal 1. So yeah, 2, 3 is a solution to that system of equations. One way to solve a system of equations is by graphing. So that's what we're going to talk about now in this video. We're going to address systems of equations that have one solution, no solution, parallel lines, and infinite solutions, the same line. To solve a system of equations by graphing, first, you graph both equations on the same coordinate plane. Second, you look at the point of intersection. That is the solution to the system. So let's take this example. Graph the two equations below. The solution to the system is at the intersection of the lines. Identify that solution as an ordered pair. So this first one right here, we can easily graph. This one is in slope-intercept form, right? So -1 is our y-intercept. The slope is up 1 over 2. We can graph that one, nice and simple. The other one is in standard form. If you recall, you can turn it into slope-intercept form or find the intercepts. So in this case, when x is 0, that eliminates this because 3 times 0 is 0. Now we just solve for y. Y equals -3 when x is 0. How about when y is 0? 2 times 0 is 0. So it leaves us with just 3x equals 6. So when y is 0, x equals 2. So plot those points. When x is 0, y is -3. That's our y-intercept. When x is 2, y is... Hey, look at that. Looks like our point of intersection between the two lines is at 2, 0. So write that as an ordered pair. That's the solution to this system. Let's check to make sure. That means that 2, 0 has got to work in both of these. 1/2 of 2 is 1 minus 1 does equal 0. That works. How about the other equation? Plug in 2 for x and 0 for y. Yeah, that works as well. So that system, the solution is 2, 0. Now what I'd like you to do is I want you to try your hand at this. So pause this video and find the solution to this system of equations by graphing. Ready, set, pause the video. Did you do it? Pause the video. Okay, I hope you paused the video. If you didn't, I'll know. No, I won't. Okay, so here is what I did to solve this one. First one's in standard form. This guy's in standard form, so I found the intercepts. Oops, that's the wrong one. Change that. Whoop. Oh, the smart board. Okay, so x plus 2y equals 4. There's that graph. And how about the other one? The green one. Find the y-intercept and the slope. Point of intersection is at 2, 1. That means 2, 1 better work in both of those equations up there. X is 2, y is 1. Yeah, that equals 4. When x is 2, y should equal 1. Yeah, that works in that one as well. Okay, so far so good. Now let's look at two special systems. I'm trying to keep these videos under 5 minutes. I know how valuable your time is. Special systems. Look at that. I graphed them on Desmos already. This is the blue line right here, and the purple line is down below. Notice they don't intersect. So what does that mean? They're parallel lines, yes, but what does that mean as far as our solutions? The solutions are where they intersect. So if two lines don't intersect, that means they have no solution. So there's no value for x and y that's going to work in both of those equations. Take a look at another special case. This one looks like what's happening here. One line. That means both lines are showing up on the same line. That means these are equivalent lines, meaning they're intersecting all along the way. In fact, there's an infinite number of intersections. So therefore, there's an infinite possible number of solutions to this special case. There is a bluebird. And finally, now find the 6.1 quick check on Google Classroom. To complete the quick check, you must get a perfect score. So that means you got to retake it over and over again until you get a perfect score. You can take it as many times as you want. Any questions, just post a reply on the Google Classroom post or send me an email.